Okay, thank you very much, and good morning all. I'm going to avoid technical detail. My colleagues will cover all these issues a little bit later on. My current role is director of this Master of Engineering Energy Systems program. I've just spent the last 4 years as Dean of Engineering in our university, and one of the things I worked on was to try to create this program. First of all, a little bit of background. That traditional engineering education structure in Ireland has been 4-year Bachelor of Engineering BE degree, and the students come in from school with strong mathematics and so on. And we've had a 4-year intensive program that hasn't typically had a placement in industry as part of it. The professional body that accredits engineering education in Ireland, Programs Engineers Ireland, has declared that from 2013 onwards that the standard for the educational standard required of chartered engineers will be that of a 5-year master's program. So what we've done over the last few years is to create a sort of a 2-cycle structure. This is in line with the Bologna Agreement on structure of higher education in Europe, where students will do most of them come into a common first year. They do some specializing in years 2 and 3. And there's a first cycle degree awarded, which is not a professional engineering one, but is a BSc in engineering science. And that really is the preparation for a 2-year master's cycle program in not just energy systems, but many other disciplines as well. So basically, the Master of Engineering is now for the future to be the professionally accredited engineering qualification and our Masters in Energy Systems, in fact, was the first such program to achieve accreditation at master's level in Ireland. So that's the background to it. The main step difference from the bachelor's to the master's that the accrediting bodies are looking for are research skills and techniques. So it's involvement in research more than design is on the agenda. So just one of the master's programs in particular that's relevant to today is the Energy Systems Engineering one. And really, it has quite a broad base, or quite a broad list of intents. And it's really to take account of the fact that the challenges on Earth are highly cross-disciplinary and multidisciplinary. And the students have a firm foundation in one branch of engineering, might be mechanical or electrical or chemical. And then they're in the master's cycle, they're looking at the broad range of interconnected issues that energy problems bring. So, for example, we have core modules on the electricity grid as part of it. So every student doing this course has to know something about electrical engineering. We have modules on building energy systems, industry, transport, etc. I'll show you the list of modules in a minute. But I mean, ultimately, we're trying to educate people to face the real challenges that the humanity faces into the future. And people not only understand them, but can actually do something about it and understand the compromises that are involved in that. We haven't called it renewable energy or sustainable energy. We have, specific modules that deal with fossil fuel extraction, carbon capture and sequestration, with nuclear power, etc. Nuclear is a relatively small fraction. It's actually illegal to generate electric power with nuclear in Ireland, according to Irish law. So there you are. Anyway, the inputs to this program, because we have a very modular structure across the university and a cross-university timetabling system. So we've inputs from mechanical engineering, electronic engineering, I'm pressing the wrong button, civil, chemical and bioprocess engineering, geological sciences, economics, and the School of Business. So, there's quite a broad range of different disciplines coming together into this program. So, a not even comprehensive list of the modules is given there. And so we have these core modules of energy systems of climate change, with this sort of overview, fossil fuels, carbon capture, chemical processes of sustainable renewable energy, essentially solar energy, and my colleague Don McElroy will describe that. Wind energy, building energy systems, energy and transport, etc., etc. We also have a suite of modules where students can specialize in electrical power systems if they so wish. And of course, students specialize through a research project that forms part of this as well. So, not every student can take every module, so it has a complex internal structure, this program. We have packaged it in 2 forms. One is, the expectation is that it will be a 2-year program for students who are coming up in the future. So they would typically, as they enter the 4th year of their engineering study, they do 30 credits, that's 6 5-credit modules in our system in the first semester of the 4th year. But then we are able to release them to go on an industry placement from January through to the next September. So that's one of my main points here, is that we have a cohort of students who will be available to go on placement in industries, preferably to work on energy-related topics. And the point is that when they come back to university to complete their 5th year, they do more modules, but they also do a substantial research project, and that could well have arisen from their placement in industry, so that they could maintain an ongoing relationship with industry. So they're not PhD students. It's a relatively, their projects are relatively short duration, master's level, but scratching the surface of doctoral studies, but obviously in scratching the surface. So basically then all the students will be available to go on this placement. We're very much looking for industry partners of a suitable, with an energy flavour to place students. The numbers have been small initially, but they're going to grow quite dramatically over the next few years. So the students will have 3.5 years of engineering education under their belt, so they're relatively mature. They will all have, to get into the master's cycle, they have to have done well, got an honours degree, and more than a minimum second-class honours in their bachelor cycle, and they will then return to the university for their 5th year to complete the project. So that's a little repeat of the previous story. We also have, just for the record, a 12-month structure for this course, suitable for students who already have completed a professionally accredited degree in engineering and don't need to fulfill a lot of more requirements in that respect. So in other words, it's packaged in 12 months, and it has 90 European credits. So they do 6 modules, 30 credits in semester 1, another group in semester 2, and then a research project over the summer. Now, there isn't an industry placement in that, but we've had significant numbers of students taking this program in this format to date, and we've had a lot of industry engagement in Irish industry of a variety of kinds, and it's been quite successful. So just to give you some idea, to date we've had relatively small numbers coming up through the 3-year first cycle and into the 2-year master's cycle, although, as I say, that's just in a state of transition at the moment. But we've been taking in, for the last 3 years now, about 30 students a year onto this program who have already completed engineering degrees. And it's been amazingly popular, in the sense we really never spent any money on advertising it. We have a rather low-key web page, and we've attracted students from a whole variety of Irish universities and from a very international mix. We've had people from UK, Spain, France, Cyprus, China, Iran, Norway, Pakistan, etc. And they've literally just found it by keyword search on the web. And we've had chemical engineers, mechanical engineers, civil engineers, electronic engineers, etc., and some of them with significant years of experience. Typically, we're getting about 90 applicants a year, and we're taking in 30. So we've been able to take in some very strong students. So it's certainly been a very satisfying program to engage with, if a little complex to administer. So to date, our industry partnerships have been, most of the students taking this program, the 30 a year, the majority of the research projects they do over the summer have been industry linked, and we've had links with the electricity industry in Ireland, cement manufacture, Glen Dimplex, Sustainable Energy Authority of Ireland, who the next speaker will explain, Mainstream Renewable Power, Board Namona, the Peat Board, and so on and so on. So there's quite a variety of different industries. And I suppose what we're really looking at is that if there are relatively small companies who haven't a track record or much experience in sort of research activity, that by engaging with us through this, a relatively low cost, low risk sort of initial experiment could take place, where perhaps the company would take a student on a placement and then work with them on a research project in the later year. And so, it's a much smaller scale than a kind of PhD project over a number of years. And but obviously, from an academic point of view, we would like a research aspect to it. In other words, that has to have a decent bit of technical meat in it. But it can be very much a way of testing out some new subject area by interacting with UCD and its academic expertise, many of whom are presenting later on today. So I haven't the contributors to this course will be speaking later on in many ways. Anyway, I think that's probably enough for the moment, so thank you very much.